Hi everyone, this is Saif Jawad, back again to explain another part about reducing code complexity. And this time we're going to use polymorphism to do it. Last time we did by this reducing complexity by displacement. So yeah, let's see what is on the agenda. So I'm going to go really quickly over what we have already covered. Then we're going to talk about reducing complexity with polymorphism and some preparation before we do the programming and refactoring. Then we do the live demo. So let's get to it. We have talked last time about different kinds of complexities. The two obvious ones that are the cyclomatic complexity and the cognitive complexity, and of course what people view as complex code. And we talked about the why. Basically, it comes down to time is money, and less complex code is easier to maintain, change, fix. So we talked about that. Talked about specifically the cyclomatic complexity, and that it is basically a measure for how hard is your code to test, and measuring difficulty of the readability, which is known as the cognitive complexity measurement. We also talked about why do we measure at all and how we do it, and basically to have a good baseline or something to hold on to, we need numbers. So numbers will tell us, okay, are we going the right direction or not? So to get those measurements and numbers about the complexity, we can use different tools. These tools, for example, SonarQube is being widely used as a platform that you put your code into, and it will tell you how much complexity you have, cognitive, otherwise cyclomatic, and you can use some on-the-fly tools that you can use as plugins in your IDE, like Code Metrics, which is my favorite for doing the complexity on the fly measuring, and CodeMR that does a whole bunch of stuff. It measures a lot of metrics like complexity, coupling, cohesion, and many others, but it is a paid plugin, so you would be more than sufficiently serviced by Code Metrics, for example, if you're using IntelliJ. So yeah, last time we talked about refactoring and reducing complexity using different techniques, and I have found out in the past years quite a few tricks and ways that you can categorize in two main categories, which is displacement and abstraction. So last time we talked about displacement of complexity using responsibility as a as our main method of removing the complexity from one place to another, and thus reducing the overall complexity. And we also talked about going to do some abstraction techniques, and I'm going to handle today the abstraction using polymorphism to reduce the complexity. Let's see. So, a few things to do before you start refactoring any code. Make sure that your code compiles and runs, that it is tested with a sufficient coverage. Have a backup or use a version control, which is the standard these days. If you don't, just use a backup, and make sure that you have already a baseline by having your code already measured before you start. So when you change stuff, you can know if you are doing the right thing, if you're going in the right direction, and this will help you gauge that. So go to the next slide and talk about what we're going to do today and how we're going to do it. So we are going to be using abstraction to reduce the complexity, and I chose just one of the techniques that earlier mentioned, and we're going to use polymorphism to reduce the complexity. How you go about that is by analyzing hierarchies in your code. So if your code uses different types of data to handle and analyze, then there might be a hierarchy there. If there are steps, then they're following each other, then there might be something there. So we're going to use abstraction based on the hierarchies this time to reduce the complexity being introduced by the if-else statements with switch statements and converting them to object-oriented constructs using interfaces, classes, enumerations, and etc. If you would like, you can check out the same demo code that I'm using and go by it the same way and do the exercise yourself. I have put the GitHub repository on screen, but I will put it also in the notes. Then you can just click it and go to the right branch of the code complexity example, download it, and have some fun with it. So, going to the live demo now. So I have already did some work and prepared this demo, and let's see what we can if we can refresh it, the project. If we can refresh the project, basically because it's showing the wrong value. It's a bit of a bug inside the code metrics plugin I have mentioned before, because it's saying now that the complexity is 5 and everything is fine. It's not. It's not fine at all, and it is not 5. So let's compile the code. Hopefully it runs. And 1, 2, 3, 1, 2, 3. Ah, look, there it is. I'm just gonna close the class, open it again. Maybe it will show the here we are. Now we are seeing the right complexity number. So it's saying that the classes has 14 cyclomatic complexity points and 13 for the method that is going to be the subject of our refactoring. Of course, as I said before we start, I have created a test that covers my code. So let's run the tests and run them with the coverage, so we can see how much code coverage we have and if it is sufficient. All right, so it says that it is 100% covered. Cool. Now let's look at the code itself. So we have a class given a very bad name, by the way. It's just called application, but it doesn't do justice. Of course, we're not talking about clean code right now. We're just talking about the cyclomatic complexity. So please ignore it for the moment, and let's look at what it does. So we are going to get a string called animal, and we're going to log the request that we're doing. So it's saying, okay, requesting sound of the animal in question. And then we're gonna do a small check that it is not null. Otherwise, so it's a little safety check, and to give information that a null animal argument is not allowed. Then we're gonna go to a switch statement, and here it comes. So in the case of the cat, We have to return meow. If it's the case of the dog, we have to return bark, and so on and so forth. Now, some people would say, okay, but this is very readable code and easy, and it's not complex at all. And I would argue that you should try to avoid using switch statements for many reasons. One of them being every time you make a change, you're actually changing the whole tree. You're introducing a change that could break something else. And that's why the use of switch statements is not my favorite. I would discourage it. Instead of this, see the complexity is going up. And why? Because every time you go inside one such block, now it's easy. We're just saying, okay, return meow. But we could say, oh yeah, register something and do something else, and it would grow. And you can go and put it somewhere else. But anyhow, every time you change it, it could grow. It could become easily more complex than it already is. And plus, too much risk involved. And you can do it easier, better, and in a way that you can introduce changes to the same code base without having breaking or the risk of breaking everything else. So how would you go about that? Well, that's what we're going to do with polymorphism. So if we analyze this, we look, all right, so we have a few things here. We have the name of the animal being checked twice, and we have a sound that it makes. So, okay, we can reduce all of these to a single interface or an abstraction, if you will, of the kind animal. I'm gonna make a new package, call it model or data. You can, it depends on what it does in your application. I'm gonna call it model for now, and then we're gonna go and introduce a new interface called animal. So we're gonna add it, and this animal has some behaviors. So it has a behavior that it can give you its name. So get name, it will return a string, and there is another string, and it will return get sound. So it's going to return a sound, and I did not type it well. Again, I am making a, okay, right. So get name and get sound, these two things. And let's start by the first animal. The first animal is cat, then second dog, cow, dolphin, and so on. Let's start with a cat. So I'm going to say new Java class, it's called cat, and it implements animal, because it is an animal, and an animal has two behaviors. So it's gonna give you a name or a sound. In this case, it is a cat, so we'll call it cat. In this case, the sound is meow, and so it gives you a sound. So we're gonna go ahead and copy this class and make a new one called dog, so that make sure we give it the right naming. So it is a dog and it barks, and then cow, and we'll add it to, and let's say the name is cow, and the sound it makes is moo, and copy that as well, make a dolphin, and we add it, so the name is dolphin, the sound it makes is click, yeah, and let's go ahead, copy that one and to a chicken and give it the name chicken, and a chicken cackle, and we have a hyena, I believe, hyena, and give it a name. Who knows what a hyena does for sound? It laughs. It's a very happy animal. Laugh. What other animals can you remember? Top of head. 1, 2, 3. I'm gonna go back to the list. So we had the chicken, we had the hyena. I missed one. It's the dove. So dove, and the dove, I'll give it the right name, dove, and the dove does coo. Coo. Lovely. So now we created all the animals that we wanted to create before, and now let's change a few things here. So instead of this, I'm going to do a minor adjustment, because we created, we have this class and it does not take string anymore, it takes animal. So it takes anything that implements the animal interface, right? And we'll take all of these, throw them away, and the if statement we're gonna put up, because it is now even, I don't think that we need the safety before everything else. So we are doing the save operation, and then we have created all the classes. Let me think. The only thing we need to do is return. We need to do a few more things actually, because the name, animal get name, that's what we need here. And we need to return the animal dot get sound. I think we are almost done. We just need to fix the tests. So the tests we had, let's see, if the animal sound is unknown, that will not work. I'm gonna move this test all the way down and do it as last one. So I'm gonna go up. So let's see, for the cat, there's new cat, right? So here we'll say new dog, done, new dolphin, done that too, new cow, did that too, okay. New hyena, also done, new dove, yeah, new chicken, right, and an unknown something. And this unknown something, I have to say new animal, and then say that the name, well, unknown, and the sound it makes just as unknown, right? So if we did this and get the animal of the sound, get animal sound, it should return unknown. So this one has been fixed. Now this is equal to, yeah, this should do it actually. We just need to, I see what I did. Actually, these tests, both of them, belong together. Am I doing this right? I think I am. Just this one. Yeah. Put it into a variable called animal. Final var. Final var. I like vars. Copy the animal and feed it into this, but we actually already did that there, so we don't need to do it again. Yeah, this should do it. Let's run the test and see if we still have good coverage of our code, right? And if everything still works. Dog is saying I missed something. So, did my dog... There's an S. See? Testing makes all the difference. We'll do it again. I love testing. Do it again. Show me that it works. Have I done well? I did. Well, that's nice. Our complexity has gone down from, I believe, 13 to 5. The code is much more readable if in this block of code that you see in front of you right now, and it has been abstracted. See, I'm not going to say it's displaced because it's not the same code. We changed the code into abstractions and we put it here. The thing is, though, now I'm going to add a new animal without breaking the code. I'm going to go copy, and we're going to add a wolf. Let's say, okay. Who knows the sound of the wolf? It cries. So it is a cry. And surely it's not covered yet because we haven't put any kind of unit test for it. And actually I should now, for each and every single class, I need to cover, because it's hard coded. It is it's not logic really, it's behavior. So I'm going to just add it for now in the test to show you that we are easily not breaking anything else. We're just adding, which enforces the open-closed principle when using this approach. Let's say wolf, and let's see, new wolf, and I would expect it to say cry. Run everything with coverage and give me that everything works. And it does. So yes, here we have it. I'm gonna yeah, it's here. This is the actually the presentation of how to use polymorphism to reduce code complexity by using abstraction. I hope it was helpful for you. If you have complex code that uses a lot of if-elses and switch statements, then you can use this method. I use it quite often together with the displacement method, but there are more. And if we go back to the presentation, let's see what we can do next time. So yeah, we did responsibility, displacement by responsibility, and abstraction by polymorphism. Maybe I'll go ahead next time and do either using frameworks or functional programming. So yeah, till next time, thank you for watching, and please, if you like the video, send me a like. And if you have a question, don't be shy and just ask your question. I will try to help as well as I can. And any kind of feedback. If I'm doing something horribly wrong, and if I missed something, and if I can add something, I would be very, 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 very glad, and I would appreciate it very much if you would give me some feedback on what I could do better. So thank you very much, and have great programming experiences.